Hello, this is Gideon Cooper. I'm the founder of Food for Kids, a ministry partner of the church at the Agape Outpost in Breckenridge, Colorado. What you see before you is a backyard aquaponics system. This is at the house of my friend Bruce Hammock. We do have a few problems with our sound today. We have a busy highway right behind us. We have air conditioner units going because this is July the 16th and it is hot. And we have the water falling in the aquaponics system. All this contributes to make it tough to hear. I'll do my best to keep where you can hear this. First I want to tell you is that this system is a beautiful example of one of the wonderful things I like about aquaponics, which is adaptability. We did not design this system and then go out and purchase these components. No, we had all these components here in the backyard and designed this system to use them. That includes the metal racks, the half blue barrels, the white piece that you see there, and its matching and larger partner over here. About the only things we bought was some PVC pipe and a couple of trash cans. As far as what's in this first tank here, this is our fish tank. We have about 20 tilapia and 3 bluegill, and I'd like to introduce you to them now. They wanted me to tell you hi. They don't know how to speak English yet. We haven't trained them that. What the fish are in is the bottom 2/3 of an IBC, or International Bulk Container. This originally shipped something like honey or molasses or any kind of liquid foodstuffs. It has about 150 gallons of water in it now, the way it's cut down. The top half is our last grow bed that has some vegetables in it. Anyway, the fish in this tank here go to the bathroom in the water, and through this pipe here, this PVC pipe, the solid waste that they, when they go to the bathroom, is brought into this trash can. We call this our solid poo collector. By the way, solid poo is a technical term in aquaponics. The solid poo collects in this trash can. The liquid poo, or number 1, goes on to the rest of the system and gets converted. What happens there is it goes to another trash can. You'll see the second one over there. By the way, all this through all these PVC pipes is powered by hydraulic pressure of the water and siphons. We have one pump in this system. I'll show you where it comes from in a minute, what it does. But the water goes, the liquid waste flows to that second tank. And over there we have this. This is our biofilter. It's just a fishnet bag with a lot of plastic. I've got some examples of what kind of things we put in there. Lids from sodas, some little jars, and even 2-liter jars we've cut up. We've got some lids from coffee creamers. We cut those up, put them in this nylon bag. It's just to hold them together, and all they do is they provide surface area for bacteria to grow on. This is what we call the biofilter, or biomedia, excuse me, and it goes in this second trash can, and that is a biofilter. Now the biofilter is home, like I say, of this bacteria, and it's the star athlete, if you would, in aquaponics. The bacteria converts the ammonia or the fish waste into nitrites, and then another bacteria converts that nitrites into nitrates. And nitrates, if you look at fertilizer, you'll see a lot about nitrates. It's basically fertilizer. And the whole system depends upon the health of the bacteria colony. And this is a natural forming bacteria that it's not artificially brought in. It forms anywhere there's ammonia and water, and the other conditions like water temperature and pH and things are correct. Now from here, or from there, you'll see the PVC pipe that goes across. The water starts going into the blue barrels, which are our grow beds. In the grow beds, we have floating pieces of styrofoam. Let me just lift this up a little bit. Just a styrofoam. And here we're growing some chives, show you the root systems on the chives. Chives are doing pretty good. The tomato plants are starting to grow tall, although they haven't started producing fruit yet. What we have here in Central Texas is two problems with our water. It's very hard and it's very high in pH. The high pH is great for the fish. They love it. They're prospering. But the plants have a hard time. High pH prevents them from absorbing nutrients out of the water, and so they don't do very well. But anyway, the water, as it goes through all this processes with the bacteria, when it gets into these grow beds, it's a nitrate, or the fish waste has become nitrates, and the plants absorb it, clean the water in effect. And when I say clean water, I'm talking about clean like pond clean. If you'll notice, when I put the camera in the water and showed you that the inside of that fish tank, it wasn't very clean, but it is a good pond. It's like a lake or a pond. It's just in plastic, so it's not pristine, but it's pretty clean for a pond. Anyway, so the water just goes flowing through all of these systems, all of these barrels, and then falls into this lowest tank. Now in that tank we have a water filter, submerged water pump, and it pumps the water back through this PVC pipe on the bottom, and it comes back to here and goes up and then falls into the fish tank. I have about 3 little waterfalls in this system. Each one of them designed to aerate the water, because everything in here needs air. The fish need oxygen, the bacteria needs oxygen, and actually the plants need oxygen too to help them absorb nutrients through their roots. Well, this is an aquaponics system. This little system, if we had good pH and were able to get it down, the hard water prevents us from dropping the pH. It becomes what they call a buffer that keeps the pH from falling very far, so we're having to work at it very slowly, because a sudden shift in pH is as dangerous to the fish and the plants as anything else, or maybe more dangerous. So from here, if everything was working right, we'd have the 25 fish or so, and we'd have about 25 plants in this little system. And once again, we just use the components that were here. I hope that helped you with a little bit on what an aquaponics system would look like in small. If you can imagine, this system could be huge. Instead of a little barrel that's 2 feet by 4 feet maybe, you could have one grow bed that might be 4 feet wide and 30 or 40 feet long, and instead of having maybe 10 plants, could have 150 plants. A fish tank, instead of 150 gallons, you could have a 4,000 gallon tank or an 8,000 gallon tank. One of the systems in Honduras that we hope to install will have close to 6,000 to 8,000 gallons, could have 1,500 to 2,000 fish in it when we reach full maturity with that system. That's aquaponics. I appreciate your interest in the aquaponic concept, and if you have any more questions, you can find my email and send it to me, and we hope that you will help us with your prayers, your time, your money. Come visit us in Honduras, and thank you once again, and be blessed.